Hi students, today we are discussing unit number 3, that is unit number 3 part 1, that is basic traversal and search techniques. In this basic traversal and search techniques we are discussed the first part of third unit, that is techniques for binary trees, techniques for graphs, connected components and spanning trees, and the last topic that is nothing but biconnected components and depth first search. Okay, today we are discussing the first topic, that is techniques for binary trees. First of all, we have to be learn about what is binary search tree. First of all, you must learn, should know what is binary search tree. Okay, it is nothing but, ma'am, it is composed of zero or more number of nodes. It should be composed zero or more number of nodes, then it is called to be a binary search tree. Binary search tree, it is composed of zero or more nodes, then it is said to be a binary search tree. Okay, in this binary search tree, each node contains a value and a reference or pointer. First of all, what is the meaning of value? Any sort of data items, if you have to take some set of sort of data items, here a value is nothing to be a, any sort of data items is said to be a value. Coming to the reference, here the node contains value and one more, it is a reference or pointer. Here listen carefully, a reference or pointer to a left child may be null, or it contains any set of data item value. Reference, here we have to take a reference or pointer to a left child may be a null, or it contains any set of any sort of data item value. And coming to the third key point, a reference or a pointer to a right child. Okay, right child, it may be a null, or it contains any data item value. Here look at this diagram here, what I mentioned here, a node, a in the sense I will take a, that is a node. Here a binary tree starting, it may be a empty, if not empty it has a root node. So here each and every node in the binary search tree that has to be reachable from the root node itself by the unique path. And here a node with neither a left child or right child, okay, is called here with neither. Here the important point here, a binary search tree may be empty. Here if not empty, it has a root node. So here every node in the binary search tree that has to be reachable from the root node by the unique path. And one more important point here we have to learn, that one is nothing but a node with either a left child or right child is called a leaf child. Okay, here look at the diagram here, all of you. Here a root node is there. A root node, if you have some left childs, okay, right childs, and left child if you have some subchilds also is there. The last child is said to be a leaf node. Here a node with neither a left child or right child is called a leaf child. Here all of you looking the here look at the properties of binary search tree. If you know what is a binary search tree, it is composed of zero or more number of nodes, then it is said to be a binary search tree. Now coming to the properties of binary search tree, listen carefully ma, otherwise you can't able to understand these points. The first key property of a binary search tree is, for all nodes x and y, listen carefully, for all nodes x and y, here the y belongs to left subtree subtree of x. Here look at this y. Here look at the diagram. Here x node will be there, and left side y node will be there. Here the y node belongs to left subtree of x. So then the key here at y is less than the key value at x. Okay, this is the first property of binary search tree. Here look at the nodes. Here x is the root node, and here the y belongs to left subtree of x node. Then the key at y is less than the key at x value. And coming to the second property of binary search tree, here look at the second property, amma. Here look at the diagram. Here x is the root node, and to the right subtree of x, then the key at y is greater than the key at x. Here look at the diagram of second property of binary search tree. If y belongs to right subtree of x node, x root node, then the key at y is greater than the key at x value. Okay, here look at the sample example of a binary search tree. Look at this very important example. This is one. Okay, is a simple example. Let us consider a binary search tree of size 9. Size in the sense a number of nodes present in the binary search tree, that is said to be a size. Here what they mention in the binary search tree of size 9 and depth 3. Depth 3 in the sense depth indicates distance from the root node, that is said to be a depth. Depth they will given in the question, depth will be assigned to 3 with root node 8. Okay, root node if we have to be considered as 8, and leaves in the sense last final leaf nodes are 1, 4, 7 and 13. Here let us consider the binary search tree. First of all, what they given in the question, root node is 8, and coming I have to be consider at the left child 8 is the root node. The left subtree I have to assume 3, and right subtree I have to assume 10. Okay, and giving the notes and leaves are 1, 4, 7 and 13 in the question. Let us I consider the root node is less than the left child. Here listen carefully. 3 కంటే తక్కువ ఉంటే దాని లెఫ్ట్ సైడ్ వేసుకోవాలి, 3 కంటే ఎక్కువ ఉంటే రైట్ సైడ్ వేసుకోవాలి. ఓకేనా, లిజన్ కేర్ఫుల్లీ. ద 3 ఈజ్ ద నోడ్ అండ్ ఐ హ్యావ్ టు ప్లేస్ 1 ఎట్ ద లెఫ్ట్ చైల్డ్ అండ్ గ్రేటర్ ఎలిమెంట్ 6 is the greater element, that's why I have to place it at right node. Okay, and I have to take in 6 is the node, and I have to take the less than 6 is 4 and greater than 6 is 7. And let us take the right subtree 10, and the greater than 10 the value will be 13, that's why I have to place it at right side. Listen carefully, binary search tree ante ఏం లేదమ్మా. లిజన్ కేర్ఫుల్లీ. రూట్ నోడ్ కంటే తక్కువ ఉంటే లెఫ్ట్ ఎలిమెంట్లో పెట్టుకుంటాం, రూట్ నోడ్ కంటే ఎక్కువ ఉంటే రైట్ సబ్ట్రీలో ప్లేస్ చేసుకుంటాము. ఓకేనా, మళ్ళీ 3 కంటే తక్కువ ఉన్న 1 ఎలిమెంట్ని మనం లెఫ్ట్ సైడ్ ప్లేస్ చేస్తాము, 3 కంటే ఎక్కువ ఉన్న దాన్ని రైట్ సైడ్ ప్లేస్ చేస్తాము, 6 కన్నా తక్కువ ఉన్న దాన్ని లెఫ్ట్ సైడ్ ప్లేస్ చేస్తాము, 6 కన్నా ఎక్కువ ఉన్న దాన్ని 7 సైడ్ ప్లేస్ చేస్తాము. ఓకేనా, దిస్ ఈజ్ నథింగ్ బట్ లెట్ us if we have to be considered a binary search tree. Here look at whatever the question they give in the question with root node 8. Yes, exactly, the leaf nodes are 1, 4, 7, 13. These are the leaf nodes. What is the depth here they given the depth 3. How the depth indicates distance from the root node. 0th level will be there, first level will be there, second level will be there, third level will be there. Okay, here what the depth indicates distance from the root node, that is nothing but depth is equal to 3. Here the leaf nodes are 1, 4, 7 and 13. Here the root node will be 8. Here the size is equal to 9. How we can get the size is equal to 9? Number of nodes present in the tree, number of nodes in the sense 8, 3, 10, 1, 6, 13, 4, 7. These are number of nodes present in the tree. That is said to be a size. This is nothing but what is binary search tree. Okay, what is binary search tree, and what in that binary search tree, if we have to contain, each node contains value. If reference to a left child may be null, and a reference or a pointer to a right child may be a null, or it may contain any set of data item value. Okay, here look at this. Here a leaf child is nothing but a node with neither a left child or right child is nothing to be a leaf child. Here we have to be study about some properties of binary search tree. If you let us consider the first property of binary search tree for all nodes x and y. Here look at the diagram. Here y belongs to the left subtree of x, then the key at y is less than the key value at x. And coming to the second property, if y belongs to right subtree of x, then the key at y is greater than the key at x. Let us consider a simple example like this manner. Okay, in later next video we discuss binary search tree traversal techniques, in the sense traversal or strategies present in binary search tree. What are the strategies or present in binary search tree? In the next video we will discuss. Up to now, thank you ma. If you have any doubts, can you please contact to me. Thank you one and all.